Hello everyone. So right now I'm going to discuss about predefined functional interfaces in Java. So in previous concepts, I discussed about functional interfaces importance as well as how we are using functional interfaces or how we are providing implementation to the functional interfaces by using lambda expressions and as well as method references, right? So now we should understand the reality of functional interfaces usage in our day-to-day programming when we are implementing any application, right? So when we observe to achieve the functional programming with respect to our Java language, and anyway, whenever we are working with Stream API, especially, we know that. So how frequently we are using the functional interfaces implementations as part of methods level. I mean, like passing functional interface implementations to the method argument values, right? So that means if you want to achieve the good knowledge as part of Stream API or to achieve finally functional programming, we have to understood very well about the functional interfaces and as well as the implementation of functional interfaces. So we defined a couple of user-defined functional interfaces as part of our previous session, and we understood how we are providing, implementing, and as well as usage of this user-defined functional interfaces, right? So similarly, now when it comes to Java, so along with Java 8 version, so whenever they are releasing these functional interfaces, features, and everything, they are given couple of predefined functional interfaces from the package called as java.util.function package. So that means inside this util.function package, we will find out all predefined functional interfaces which are provided by the Java language. And out of all these functional interfaces, we know that couple of interfaces are there with respect to implementations we are using everywhere, especially in Stream API functionality. Generally, we will use all these predefined functional interfaces and implementations as part of Stream API methods. Not only Stream API, even we are going to use the same functional interfaces in different other scenarios also. So I would like to explore now. So what is the real importance of predefined functional interfaces, as well as I would like to introduce the more popular functional interfaces, especially function, predicate, consumer, and supplier. So these four are the popular functional interfaces which are being used everywhere in our day-to-day programming. So I will try to cover the use case of every functional interface, especially these four, and I will take some couple of examples for every internal abstract method as well as if there are any predefined default or static methods are existed as part of these four interfaces. Okay, so let's start one by one. So initially what I'm doing, so I'm going to take now the more discussion about the functional interface of function. So if you see here, this function itself a predefined functional interface from the package called as java.util.function. So let me open the package now. If you observe here, we can find a lot of functional interfaces, especially inside this package, like by consumer or whatever it is, right? But especially, I'm going to discuss more about the function as well as predicate, supplier, and consumer. And the remaining all functional interfaces, whatever we can see here, those are all derived from these four types of functional interfaces, what we are discussing right now. So once we are good with these four functional interfaces, even we can easily understand the remaining all functional interfaces which are listed here, okay? So let's move to the function interface first, and then one by one, we will try to discuss. So now I'm talking about the function functional interface. So what is the meaning of function functional interface? Why Java language provided function interface especially? So this function interface, we can consider it as a utility function as part of our programming level to apply any functionality to the given argument. So for example, let's take a scenario like this. Whenever I have an element or an argument and I want to process that argument with some logic or maybe some manipulation I have to do with that argument. And then finally I have to return some other value. So that means here as an input I am passing one argument, and at the same time after making some calculations or maybe some functionality, applying some functionality, then I want to return a value. So this kind of functionalities we can achieve with the help of functional interface. So that means when you go to the function interface abstract method, especially So let me show you here. So now in this case, if you observe here, we have only one abstract method, single abstract method called as apply method. So what it was saying here, it is whatever the given value. So here the method argument representing the input argument. So once you are taking an input argument, and if you are applying any business logic or maybe any logic to the argument, and then you can return a value. So that means by using this function interface, we can take one input value and we can process it, and then we can return the result also. If you have such kind of requirement in any scenario, then we can use functional interface, and we can pass that interface reference wherever we want as an implementation to achieve same functionality. And even if you observe here, there are a couple of other predefined methods also available, like and, then, compose, and identity. So we will come back and we will discuss each and every one. So now let's start discussion about the apply method. So what this method is saying, just clearly understand now. So we are going to apply this function to the given argument, nothing but whatever the implementation we are going to provide as part of this apply method implementation by using either lambda expression or maybe method references, right? The same functionality we are applying to the given argument, and then finally we are going to get a return value. So for that, let's create a small example and let's try to understand practically how this method we are going to implement, as well as and in what scenarios we are trying to use this respective function interface. Okay, so now let me create a project. So I have created a project now. So yes, I have created one Java class now. So inside this, for example, if I have a requirement, so in this case, just I'm giving find half value from given value. So this is what I just give. So what is this? I'm going to pass one value and I want to get half value from that. So what I'm going to do now, so as per functional interface, we know that we can provide implementation by using lambda expressions. So what is our interface here? Function interface. So let's take function. So if you see here, java.util.function and file, and this here, when it comes to apply method, so let's discuss the one abstract method called as apply. Yeah, this is what the method. So here, P representing the input type value, R representing the return type value. So that means you can pass any data type value to this method argument, and at the end we have to return a value mandatorily whenever we are taking this function interface. So for that, what I'm doing, see here, I'm going to pass input value as an integer type, and I'm expecting the result as a double data type. So here, half value. So just I'm giving a reference and I'm providing. So let's assume I'm going to give a value, and you know that as part of method lambda expression implementation, when you are having only one method parameter, you can define that here, and you can divide I by 2. Okay. So that means what is the point here? It is, so here I'm just providing implementation, like I'm providing integer value, and on top of integer value I'm just applying by 2 divided by the 2 so that I can get the half value. So see here, now we know that generally how to call the implementation of the lambda expression by using the actual method. So I'm calling now the apply method, which is part of this function interface. So here I'll pass initially like 10, right? And if you see the return type of this method now, what is this? Double data type, because we defined return value as a double here. So let me make sure the double data type result equal to like this. So see here, now let me print this value 6 out of. So let me execute now. Yes. So if you see here, the input value we given 10 and then got value as 5. So what is the advantage of these methods? Here it is with respect to functional interfaces. Tomorrow, whenever you are having any kind of requirements, okay, for example, you have to pass a string value and you want to make sure everything is converted as uppercase, and again you want to receive the value with the uppercase value. So as an input we will use string data type, and output also we can define string data type, so that the given string will be converted to the uppercase and returned as a string again. So and that is how you can reuse as a utility functionalities wherever we want, instead of defining one more separate method or maybe some implementation as part of the classes and all. We can use this respective predefined function interface. For example, let me take one more example for the same. So what I'm going to do here it is, I'm just trying to convert given string to the uppercase, right? So what I have to do now? So let's define our function implementation. So what is the input data type? String value. And what is the expected output data type? String value. So then I will provide implementation something like function 1 to uppercase. So what is the input value you are giving? One single string. So I can define as part of lambda expression as a method argument, and then I can do what? S dot to uppercase. Yes, right? If I can provide implementations, or else we can provide implementation as like by using method references also in place of lambda expression. So this we discussed in the previous session how to use and where to use method references as part of implementation of functional interfaces. So what is the method? To uppercase, right? So by using method references, I provided implementation instead of lambda expression. Fine. So now let me verify whether it is really returning string value or not. So what I am doing here, I am directly applying function and I'm just passing apply method. So we know that whenever we provided implementation to the functional interface, we are going to call that abstract method. That means this implementation comes as part of the abstract method implementation. So we are calling that abstract method and we are passing the actual value. So see here, I'm passing my name, Dilip Singh, and let me print it so that what is going to happen in this scenario, what we are expecting here it is. So whatever the value we are passing like Dilip Singh here, in this case, it is going to be passed an implementation like to uppercase, and it will convert the entire Dilip Singh as a uppercase letters, and that value is going to return as a string value in this specific scenario. So that means in the overall implementation level, what value you are going to get? Return. The return value is string result. So then we are trying to print the return value, whatever we are receiving. So it has to print everything in the uppercase. Okay, I'm just executing the program now one more time. So see here, you got the entire value as a uppercase value. Similarly, I can use the same function implementation in any place again also. So like system.out.println. So again, I can use function one dot apply method. Even I can give so like Java features. So see here again, I'm reusing the same function interface here also. So after executing, I can get again the Java features in the uppercase also. So like this, you can define any input value you can pass, and you can expect based on the requirement what is the return value. You can provide implementation as part of this lambda expression, or you can define your own method implementation also as part of lambda expression, right? So this is how we can define apply method from this function interface, and we can use this reference wherever we want. Even we can pass this reference to the other method arguments also. We can define method argument with this function interface, and we can pass this implementation also, right? So let's discuss a couple of examples related to the static and default methods which are available inside the same function interface. Okay, so what we will do, first we will discuss one by one what is the purpose of this default methods and static methods provided by the function interface. Okay, so generally sometimes what will happen, we have to compose an implementation with couple of function interface implementation. So nothing but I want to make sure in an order one action should happen first. That means one functionality should be executed and immediately one more functionality has to be executed. So that means I'm just composing the actions one after another. Okay, so that is all, right? So that is the purpose. They given couple of methods here. So if you observe here, and then and compose method, especially for all about composing a function interface, is nothing but make sure one function is executed once, and after that immediately followed by one more function. So I will show you very clearly how it is going to happen, what is going to happen as part of this default methods, especially and then and compose. If you observe here, these two default methods are taking input as a function reference and as well as returning again function references. But at the same time, we have to understand what time we have to use out of these two default methods, right? So generally, whenever I have two function implementations, function 1 comma function 2, okay, and then I would like to make sure one function, whatever the function I have, main function, I would like to apply the some functionality, and then again I want to apply some other functionality. So that means I want to apply two functionalities to the given input value. So I have single input value, but two functionalities has to be done at the same time for the given value. So that means, for example, assume I have a scenario like this. I'm taking a string called as a string value. Okay, fine. And then I want to make sure step number one, first of all, is it null or not? Is it null or not? That is one functionality. It's all null check. So that means it's a single functionality. Second step is if it is not null, then I want to make sure it is converted to the uppercase. So this is what I have to perform in this case. So what it is, first functionality is it null or not? I have to check. In case if it is not null, then I want to make sure converting to the uppercase. If not null. Okay. In case if it is null, then I will ask user to enter valid value. So this is what I have to perform. Then what I have to do. So for this, what I will do, I will write down one function implementation here. Okay. So we're checking, first of all, the given value is null or not, right? And then I will write down one more function implementation. Okay. And I will see if it is not null, converting to the uppercase. If it is null, then asking him user to enter the valid value, right? So this is how I'm going to do that. So that means in a sequence, first this thing should be happen, and then this should be happen. So that means if I give an input value now, for example, the value I given as a Dilip, what should happen now? First, which functionality should coming into the picture? Function 1 should come into the picture, right? And then function 2 has to coming into the picture, right? Yeah, let's implement this now in a programmatical point of view, how we are dealing with and then method, especially in this specific scenario. So generally and then method will be applied in such a way. First, what is going to happen? First step number one, this function 1 will be executed. So once whatever function 1 is executed, and then okay, second functionality will be executed on the given value. So whatever the given value we have, so step number 1, it will verify with respect to null or not. So in case if it is not null, then it is going to convert everything as the uppercase value. In case if it is null, then we are going to see an enter value. So this is how the and then method. So that means execute this first and then execute this. So like that, in a sequence, we can execute number of functions by using this method. So let's implement this now, how we are going to do that. Okay. So let's define one more functional interface for what? Null check. Okay. So what I'm doing, I'm taking one more function interface, and here also input value is string and output is also I'm going to take as a string. So it's all about function 2 I'm implementing as a null check. Okay. So this is given string. Then I'm going to verify if string equal to null, then simply return enter valid value, right? Okay. If it is not null, then return same value. So I have defined one more second functional interface implementation, like if string is null, enter the valid value. If it is not null, returning the same value, right? So now in such case, based on our requirement, what we have to do, first what we have to do, we have to do the null check. And then, so that means null check, please perform this action first, and then, okay, perform uppercase. For what? For given input value. So I'm giving finally a value here. Okay. So this is Dilip Singh channel. Okay. So this is what given string. So in such case, what is happening now? As per our previous explanation. Okay. So this is the value we given, right? So this value will be passed to the null check. And once at null check level, what it is going to do? So this functionality will be executed. So is it true or false? So here it will become false. So that means then it is going to return the actual string value to this what? To this output, to this whatever the value you are returning. So you are returning what? String. The output of this is written here. And then again this value will be, then this functionality will be executed. It is step number 1, and then it is going to be executed in the given input value from the string. So now this is Dilip Singh is the not null value, and you will see everything in the uppercase. If it is null, then you are going to see this message is going to return again as part of this method, right? So then to this method implementation, and then again that will also converted in the uppercase like enter valid value in case if you given in the null pointer. So let me collect this result also. So whatever the value I have, so sys value, and then let me execute my functionality now. So see here, this is Dilip Singh channel. So what happened in such case? So that means if it is taking here, coming here as a, so this is what executed first, and then not null, return the same value, and then applied uppercase functionality. The second functionality is applied on top of this result, whatever came from here, right? So that's why you can see Dilip Singh as a uppercase point of view. For example, let's see if I given same null here, what will happen now? Yes. So in this case, null, that means again this functionality will be executed first, then it will come here, str equal to null, then this value will be returned. This value will be returned for this method implementation. So that means in this case, what is the input value? Enter valid value, and that is also converted to the uppercase. But you are going to see now output as enter valid value in the uppercase format. Okay, so let's see here true or not in case if I given null. See now when I provided null, then this is what happened. So that means in simple what we understood, we are just making sequence of functionality execution for the one input value, like especially and then method will be executed, okay, right after apply functionality. So that means it will apply functionality and then this will be executed. So now similarly, let's discuss about the another method called as compose method. Okay, so what compose was saying here, returns a composed function that first applies the before function it is input. So that means it's just like opposite to the and then method. So in and then method what happened, first whatever the functionality we provided in the first place that will be executed, and then whatever we pass it to the and then method reference method argument level, that is what executed in the second place, right? But in this case what is going to happen, on top of which function reference you are calling compose method, and whatever the function reference you are passing, out of these two what will happen, first whatever you pass it to the method argument that will be executed, and then the result value will be passed to the actual main function what you are calling that will be executed. It's just like little bit opposite to the and then method. So for example, I'm not taking new example, so I will just make sure the differentiation between and then and compose here itself. For example, let's see, I'm taking same example, I'm just converting and then to compose. Then what is going to happen, we will try to see here. Okay, so what I'm doing here, so in place of and then I'm just making compose. So if it is and then, we understood first and then second. Now in this case, first this will be done and then it will be done. So that means whatever the value you are passing now, okay, so let's make sure this is compose. Okay, so what is going to happen now? It just this value will be passed to this functional implementation. So that means first uppercase value will be executed, and this functionality will be executed, and the result, whatever the uppercase value result, is passing to this functional interface, right? So this is what happening here. So this is first now and this is second now. In earlier case, when if it is and then this is first and this is second. Okay. So this is all the difference between compose. So compose in the sense it's all about before. So it's all about and then is all about after. So this is what past executing after. Okay. So this is what executing before. So that means before. So this is what they are explaining as part of these two abstract methods. Okay. So let's see the execution ones again. So let me print again same value also here also. Okay, so I'll just write down a simple this is functionality of compose. Okay, so just making sure from the previous output is different. Okay, so see here, this is compose. So what happened? First, this is executed. So it went into the uppercase. Yes, it is converted. And then it returned to the null check. Then what happened? It's anyway not null. That's why it returns string. Now observe here what I will do. I'm just passing here null. Okay. So now in this case, you will come to know that which is executed. Okay. That means in case if it is executed first, what will happen? The null value is trying to convert it as a uppercase. But we know that we cannot convert null to the uppercase. We'll get some null pointer exception. So that means at this function implementation, okay, like before this implementation itself, I'm getting the null pointer exception. So that means it's not at all reached to this one. So let's understand now, is it true or not? So see here, you got something like null pointer exception is nothing but what happened here. It just trying to execute this functionality first and then this one. So that means before applying this is what applied. So this is before. I mean, this is after, this is before. You got the point now? So it's just quite opposite to the and then method. So in such a way, we can combine multiple function interfaces implementation to perform sequence of activities. So even we can combine and then as well as compose also in an order, so that you will just need to make sure in which order we are trying to achieve or execute the functionalities on the given input value. So we are giving only one input value, but it is in a compose or in a sequence of actions, multiple functionalities you are trying to execute one after another with the one given input value. So it's something like chaining the functional interface implementations, executions. So now, and we have one more predefined method from the function interface, but it is a static method and call it as identity method. So if you observe this identity static method, it's not taking any input, but it is trying to say it whatever the input value we are passing, same value will be returned as output. So returns a function that always returns its input argument. So that means simply what you are passing, same thing will be returned back. But well, somewhat it is interested, like why we need to question something like, so what is the meaning of passing value and receiving same value? Here it is. So that means in couple of very rare scenarios, we are going to use this method. Out of that, I'll try to give one or two scenarios. Okay. So generally as part of identity method, so let me take this. So now we are discussing about identity method. The real use of this identity method is actually, yeah, it will be used very often, but the real scenario is something like where a function is required, but no changes should be applied. So that means in simple way, I can say we want to pass some dummy function where we want to, wherever we have a dependency of function implementation. That means when you are passing this identity method, so it's just fulfilling the functional implementation. At the same time, it's not performing any activities on the given input values, and it will give same thing as a output values. So, okay, so that is how this method is going to work, and it is a static method. So that means we have to call this method always with the help of function interface name only. So let me take one example, a basic example how it is working. So it's all about static of identity method. So what I will do, I will define a function and given value is integer. So you know that it is always going to return again same integer value. Okay, so identical, it's just like identical things. Function of, see here, I don't want to perform any action, then I'm going to make sure this method is called identity method. So see here what I will do. So just calling system.out.println and identical value dot apply. So I'm just passing some 100 value here. So if you see here, I'm passing 100 value here, and it will not perform anything on the 100, and it will return same value. So that means integer you are passing as a function identity here. So let me return here. Yeah, let me execute now. See, it is providing 100. For example, let's see here, I provided double. So see here, what is the error you are getting? Type mismatch cannot convert from object to object, because the reason is it is saying input and output data type should be same. Then only this identity function will work. Okay, so this is one scenario I can tell you. And second scenario, I mean, this is how generally we are going to use. The actual scenario, for example, if you are having any idea of Stream API, okay, so I will cover in the next session the entire details about this Stream API, right? So when, as part of Stream API, assume I have a stream object. So I have a stream object, and from that I have to collect. From that I have to collect all values as a list. So what is the output? What is the requirement here? It is I have stream object ready with me, only stream object, and then from that I want to collect all values as a list of values. So that means what I will do here, I will take a stream object first. Okay, followed by, for example, assume I have string, and I'm taking like names stream of, so I can pass any type of values here. So something like 21, comma 2, comma 3. So assume I have more values like this. Now what is this? It is a stream object. And what is my output now? From this stream object, I want to collect all values as a list of values. Then what I have to do? See here. So in such case, generally what I will do, see simply I would like to take a map functionality, but map, you know that it will always expect a function implementation, but we don't have any function implementation because we are not doing any transformation of the data. We are not modifying anything, right? So we want details as it is. So in such case, what I can do to replace the function implementation, I'm using function dot identity method. Function dot the identity method I'm using here, and then simply I'm writing like collect us to the list, so that I can get a list of string values. So generally this is how we are going to use, but very rare case we will use this method, just where we want to replace like this a dummy implementation as part of function implementation. See, now it's got. So this is all about the function interface, which is provided as part of the java.util.function package, like as a functional interface. So we discussed all the methods as part of function interface, where and all we have to use what method. We taken couple of scenarios and everything, right? So now let's start discussion with another function interface, functional interface from the same package called as java.util.function, and the second one what I'm taking here, it is predicate. So now I'm going to discuss more about the predicate functional interface. So when you are good with this function, understanding whatever we had till now, so we can easily understand now the upcoming functional interfaces what we have like predicate, consumer, and supplier. Okay, so let's start with the predicate now. So before entering into predicate details, what is the meaning of predicate here? So predicate, we can consider it as a condition. So that means generally when we are making our programming, we used to write down a lot of conditions and we will try to get the Boolean results, right? So wherever we are having any functions, those are all expecting a Boolean value functionality. So that means Boolean valued functions, right? So in such cases, we can use predicates. So that means when you are observing the predicate here, so if you see here, predicate is just representing a Boolean valued function of one argument. So that's nothing but, so if you observe here, the predicate contains one single abstract method called as test method. And here it is taking only what? One input type, and it is always producing return value as a Boolean value. So that means what is the meaning of this test method? What is the meaning of what is the agenda of predicate here? It is especially very simple. Like when you want to process an argument and you want to make sure the same argument or the same value has to be processed by a condition also. In such kind of scenarios, we are going to use the predicate implementation in any methods level. So that means, for example, I have a list of employee objects, okay, and I want to see how many employees are having greater than 25,000 salary. So in such case, generally what we will do, we will write down a for loop and we will write down inside that maybe if condition. So nothing but we are processing one object after another object and we are verifying salary is greater than 25,000 or not by using the if condition, right? But when it comes to nowadays as per functional programming and when we are processing the list of employee objects, maybe assume we are processing by using Stream API and I want to filter the values or the objects which are having greater than 25,000 salary, right? So in such case, I will process one employee object and I'm validating he is greater than 20,000, 25,000 amount or not, right? So those kind of scenarios we are going to write down predicate implementation and we can pass that predicate implementation as part of the method representation or method argument level or wherever it is, we can use the predicates and simply it's all just like replacing the functionality of a conditional things for any given element. So how and all we will try to understand. I will try to give you the clear details about the predicates with couple of examples. Okay. So and after one abstract method, if you observe, even we do have in predicate couple of default and static methods. Okay, if you observe here, and is equal, negate, and as well as or methods, right? So these are all I can call it as conjunction methods. That means we are conjunction of predicates, like adding multiple conditions, nothing but adding, or we are just applying multiple predicates on given value. So like that, we can consider these methods. Anyway, we will have one by one example for every default and static methods also. After first, we are discussing about the test method as part of predicate interface. Okay, so let's take an example here how we are going to define the implementation for the test method and how we are using the predicates in a simple examples we will try to cover now. So now I'm just taking a very basic example right now and then slowly we will try to improve other examples with some complexity. Okay. So for example, assume I need to verify I have a requirement something like verifying age is greater than 21 years or not. Okay, so this is what I want to verify. So here age value I'm just considering as an integer value so that when I'm defining predicate, we already discussed predicate is going to take how many values as an input to the actual function abstract method of test, only one value. So and what value you are passing to the predicate implementation, that data type you have to provide here it is. So that means whatever we provided the type here, so it's just like a method argument type also, whatever we discussed in the test method. So here I'm just providing implementation in a way lambda expression. Yeah, here I'm just providing implementation by using lambda expression implementation. So whenever my method is having only one argument and I'm just taking only one argument here, and I'm just writing age is greater than 21 or not. So that means what is the condition here I written? What is the implementation? This is what the implementation. When how input value, something like I'm passing input age value, and I'm just checking the respective input value is greater than 20 or not. 21. So that means if it is greater than 21, then you will get the true. If it is less than 21, then you will get the false. Either 21 or less than 21, we will get the false value here. So see here, now you know that generally how to execute the functional interface implementations by, right? So for example, I'm just taking the instance of our implementation and I'm calling what is the method? Test method. So the implementation of test method is this is what. So I'm just passing my value here. For example, I'm giving right now 32 here. So now that means the 32 value, whatever you are passing here, and it is just checking like 32 is greater than 21 or not. Yes, it is greater than. So the what is the output value here? It is right. Similarly, if I am passing any value less than 21 or maybe 21, so then for example, assume I'm going to pass one more value, something like 18, and it is checking internally 18 is greater than 21 or not. Yes, it is false. Then it is going to return false. So generally these kind of scenarios earlier we used to take care as part of if conditions, directly implementing at the if conditions point of view, right? Generally. But now we can use this one as a whatever the predicate we define with respect to check, check or whatever it is. So we can use this as part of our conditional statements also. So when instead of again you are defining the implementation based on our conditional statements level, you can directly use these predicates also. Okay, so for example, so let me just give that what 18 also system.out.println. So that means I'm just checking age check dot test of maybe if I given 18 years, then expected output is false. Right? So the predicate of result here it is true and here it is false. So see here, yes, it's just like working as a conditional on input value here it is. So tomorrow, even you can use these predicates as part of our conditional statements also. See here, I'm just checking if age check. So the implementation we have to use, right? So I'm just passing a value here. Now simply this out allow or eligible. So let me write down it as eligible. Right? In case otherwise, it will become false. So let me execute now. See here. What is this? You got eligible. So that means even you can use the predicate implementations as part of our conditional statements also wherever we want. Instead of again, we are defining the conditions in our conditional statements level. Okay. So that is what one of the big advantage of the predicate. And let me take one more requirement here it is. For example, we decided, right? So we had an example like who we want to find out an employee from the employee objects who is having greater than 25,000 salary, right? So let's take same example here also. So for that, what I'm doing first, I'm creating a class called as employee class with some properties. So let me define the employee class quickly now. Private integer ID, private string name, private double salary. Okay, so let's define setter getters all for this. Okay, fine. So I just created a simple employee poser class and let's come back to our class name. So what is my requirement here? It is I would like to verify the employee is having greater than 25,000 salary or not. Right. So let me create a employee object right now. Employee E1 equal to new employee. Okay, fine. I will just set some values. For example, E1 dot set ID. I'm just like setting a value and as well as E1 dot set salary. And I'm just checking values I given as a 24,000. Okay, so now I would like to verify this employee is having greater than 25,000 salary or not. And I would like to use predicates in this scenario also. How to define predicates for every employee object. See, the condition what we have to evaluate here it is every time I want to identify an employee's salary is greater than 25,000 and I want to reuse that logic in my implementation in couple of places. So then I'm going to define a predicate. Here it is. So how? Let's define predicate. And this time what is the type of value you are passing? What is the argument? Employee type. So that means employee object you are passing in this scenario. So let me do one thing, employee salary check, something like that I written here. So and then that what is the input type this time? What is the method argument type? Employee. So I just taken employee as a method argument, and then I'm just making the logic something like employee dot get salary is greater than 25,000 per. Okay. So this is what the predicate or the condition I define for an employee object. Now, wherever I would like to verify employee details with respect to salary, I can use this predicate implementation, right? So for example, if you see here, if employee salary check dot test, so that means we are testing with respect to employee one is really valid employee, or maybe he is having greater than 25,000 salary or not. Okay. So that means it's out above 25,000, right? So or else I can write down below 25,000. Simply just verifying the data now. So let me execute program once. So if you observe here in the latest line, what it is below 25,000. So that means now what happened again in this scenario also? The same employee one object, whatever you are passing here, that employee one object is passed to here. Now from the employee one object, it is picking the get salary. So what is the get salary here? 24,000. Right? Now 24,000 is greater than 25,000. So obviously it is false. Right? So then that's why it moved to the else condition, and this is what printed. Now let's do one thing. Let me verify. Let me change the salary from 24,000 to 26,000. Then same scenario will be repeated one more time. So now guess this will be printed, right? So this is how we can define the predicates for any given input type, object or values, what we defined at the predicate type level. So we can define any complex conditional checks as part of single predicate implementation. See, for example, assume tomorrow I have a requirement and I want to see salary is greater than 25,000, and okay, people, I would like to select employees gender is what? Maybe female. I want to make sure this kind of condition check. So some requirement point of. Then what you can do? As part of this predicate check level itself, you can define employee greater than salary, get salary is greater than 25,000, and you can define employee gender is female or not. So that you can use that new predicate wherever you want. In a single shot, it is going to verify the employee salary as well as the employee gender is matching or not. In a single shot, it is going to verify, and you can reuse that condition, or maybe you can reuse that predicate in any conditional statements level, or maybe anywhere else. A function is expecting a Boolean argument also. So there also, if you want to pass dynamically data, you can use the predicates. That is what happening in the Stream API when you are using the filter methods, especially. So filter methods are always expecting generally a Boolean value function. So those there we can provide simply predicate implementation, so that internally filter method will execute this logic implementation, and then it will try to pick up all the values which are satisfied the conditions, right? So this is how we are going to use the predicate implementations. So now let's start discussion about the other default and static methods available inside the predicate interface. Okay. So before entering into the default methods, what we can see, especially in this case, first one is called as and second one is negate, and as well as third or methods. So if you maybe somewhere else we heard about and negate as well as or operators, right? So it's nothing but in our Java, when we are learning in our Java, we have a concept of logical operators. So what we have logical operators in this case, So we have something like AND operator as well as OR operator as well as negate operator, right? So in this case, what is the meaning of it is both are true. I mean, conditions all are true, then you will get the result is true, right? In this case, either of them is true. So when you are having either of the conditions are true, then the result is right. Otherwise, false. That means both are false. Both conditions are false at right hand side and left hand side. Then that means both are false. So then the result is false, right? So, and when it comes to not operator, what we know, for example, when you have true operation and you want to make it as a negate operation, nothing but negative way, just opposite things. So when you are applying negate, what is going to happen? It is becoming false. Similarly, when you are applying negate of false, it will become as a true, right? So these are all logical operators we remember, right? So same thing here also we are going to achieve by using these three methods, but with respect to predicate implementations. That means as by using predicate implementations, when you want to combine or when you want to conjugate couple of predicates and you want to get one more final predicate, okay, so we can use these methods. So that means in this case, what is going to happen? Just guess now. So in this case, what is going to happen here? It is, for example, I have predicate 1 now, okay, and I have one more predicate also. So I can define predicate 1 and something like predicate 2. So in this case, what will happen? P1 is nothing but just this AND is operating. So this AND is operating now as a logical AND operator, what we discussed in the just right now, right? So that means now P1 predicate is true and as well as P2 is true, then only you will get true result in this case. Then only will get true results in this case. Same, it's just like similar to logical AND operators. Now similarly the OR method, whatever we saw right now, like predicate 1 dot OR of predicate 2, if you apply, what is going to happen? The result. So when you're passing any value to the this final predicate, wherever you are applying the conjunction with the OR method, either of them is true, then you will get true result. If both are false, that means the result is what? In case both are false, then only you will get the result as false. In other scenarios, you will always get a true, right? So same kind of functionality we are going to achieve with these methods when you are using the predicates. Now similarly, we have one more method called as negate, right? So negate is not taking any input parameters. So that means if you apply p1 dot negate, that means predicate 1 dot negate, what is going to happen? So once your predicate is executed, whatever the result comes, it is just going to convert it into the respective opposite value. For example, predicate result is true, then negate will apply with respect to false. So if predicate result is false, okay, then if it is false, then it will be given finally as a true because of negate operator. So this is very simple when we are understanding the logical AND OR operator as well as negate operators. Where there we are having operators concept, here simply they provided as a methods with respect to predicate implementations. So what I will do in this case, let me quickly define couple of examples in this case also. So see here, I already have a employee salary check, right? So let's take same example only. So where I would like to verify gender is female also. So what I'm doing now, I'm just trying to make sure creating one more predicate, okay, for the employee, and I'm just checking it's all gender check, whether female or not. What I'm doing is just making female check. I'm just doing every with respect to employee object, employee information, okay. So what I'm doing in this case, yes, employee, when I got an employee object, I'm just checking like employee dot get. Okay, sorry, we don't have any gender property in the employee, right? So let me create a gender property to fulfill this requirement. So let me add a new property quickly, string, and followed by the gender. Okay, so let's add setter getter methods also. Source generate setter getter methods for the gender also. So yes, now I just added gender property, right? So see here now, go to the here. Now let's just get the gender. Okay, is it equals to dot equals or ignore base? Just I'm checking whether female or not. Whether female or not. Okay. So what I have written now, one more predicate I have implemented with respect to female checkpoint. So now total, this is for only verifying the employee salary. This is verifying for the employee gender, especially female or not. Right? So, but if I want to execute this requirement and like and operator point of view, it should be greater than 25,000 and at the same time gender should be female. So then guess it's what you have to do. You have predicate number one and predicate number two. So that means you just need to combine both with the method called as and method. So that means let's see here what I will try to do. I will pass an employee object. Okay, so what is the employee object we have? Employee one, right? So what I will do, employee one dot set gender of female. So I just given gender as a female in this case. Okay, fine. And then next, what I'm going to do, apply both predicates with the and operator. So what is about my first predicate? Salary check. And 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 the next predicate is all about female check. And the for the person or for the employee object of E. So now guess what is the expected result in this case? What is the expected result, whether it is a true or false in this case? Yes, employee one wise. So having 26,000 salary, yes, true. And similarly, one more predicate you are applying female check. Yes, employee is also female. So that means you are true as well as true. You are getting for the employee one object. So final result is, so let me take it as Boolean. So that's what the meaning of Boolean valued functions when we are discussing about the predicate introduction. Okay. So let me just make sure very clearly what the output you got with the result. Okay. So just understand the last statement, what it is being printed. So what it is true here, it is printed. For example, assume now the employee is male employee. So we know that whenever we are using AND operator or logical AND operator point of view, the same functionality we are seeing here also, right? So employee salary wise, yes, true. But when it comes to female check point of view, it's getting false. So that means true and false, it's all about false. So based on the AND operator, right? So let's see the result now, whether it is false or not. So yes, it is false. So that's all. It's very simple, very straightforward when it's similar to logical under logical operators, but there we are using operators. Here we are using methods with respect to multiple predicates. One predicate is nothing but one condition we can consider like that. Now guess what is the meaning of OR method? So when you are opening the OR method implementation, okay, so you are just taking or returns a composed predicate. So that is going to apply logical OR operator. Means either of the condition is true, then it will work. For example, assume you have a requirement like you want to verify salary is greater than 25,000, or you have a requirement like gender is male, something like that. So then what you can do? So you just apply both the filters with respect to our operator, what is going to have. See the result now. So let me copy paste this and I will remodify to the R method here. Okay. So good. So now let me print my result. Okay. So here what method we are using? R method. So employee salary, yes, greater than 25,000, true. You know that whenever first condition itself true, then the entire R operation will become true. So it will become irrespective of female check. So let's see whether it is true or not. So it is printed. The reason is employee salary wise good. Now let me make employee salary as below 25,000. So that means in this case, what will happen? Employee salary wise false as well as female check wise false. Then false or false, it's nothing but finally false. So let me execute. See here again, this one also became a false, right? So now similarly, what about the negate method? Do you need to worry about the negate method? So that means it's nothing but simply printing the opposite value. For example, see what I'm doing. I'm just applying negate one of the predicate. For example, I want to make sure female check dot test of employee one. Okay, so I would like to print if it is female check. I want to make sure not female. I want to filter employees off, or I want to find out male employees by using the female check. Then what we can do? Simply we can apply the not operator, right? So similarly here also what you can do? Yeah, simply apply the negate method now. So then just see the result now one more time. What is the result? So you know that now with respect to employee one, what is the result? For example, let me make it as female now. So now with respect to employee one, yes, female check wise, you are going to get the result true. But you are applying what? Negate operation. So that means the true result is becoming as a false. Okay. The true result is becoming as a false. See here, false. So that means condition became true, but result given as false. It's just like the entire predicate result is converted to the opposite Boolean value. That's all about the negate method. So this is very simple related to the logical operators. Okay. So you can conjust any number. I mean, that means you can combine any number of predicates or you can join any number of predicates. So that is all about the predicate default methods. Okay. But when you are observing here, we have one more method called as, but it is static method. It is equals of an object target reference. So what is the meaning of is equal here? What is the meaning of predicate? What predicate is doing with the is equal method here? Let me explain you here in a very clear picture. Okay. So here, generally the purpose of, if you observe here what these guys are saying, returns a predicate that tests if two arguments are equal according to the objects dot equals of method. So when you go to the objects class, generally you have a equals method. Inside that, generally they will check the equality of object content, right? So for example, assume in object 1 you are having same content with respect to properties. In even object B also you are having same content. Then equality wise both objects are same, right? Content wise internally, that is what the meaning of equals method. So similarly, in our requirement point of view, for example, assume, okay, so your requirement is what? I want to take one employee. Okay, one, for example, assume I have an employee, or based on this employee property values or whatever it is, I have to validate other employees. Have to validate other employees. So let me give you an example in this case. But one thing what you have to do here it is, in this case we have to override, okay, inside employee class we have to override equals method. What it is, based on the equals method, we have to override. So then internally the overridden logic of equals method is taken care by the equals method, what we are calling on top of the predicate, and when you are passing this second object also. So how the things are going to happen? Let's open the employee class and let's define the the equals method also. Okay, I just defined now an equals method. So what we are doing, just it's all object type, so superclass type, typecasted to the employee, and I'm just checking employee ID. Yeah, employee ID with respect to object was 1 versus object 2, both are same. Then I'm feeling like both employees are same. So that is what I written the condition here with respect to equals method implementation. So now see how I am applying the predicate here with respect to, so predicate, I'm just defining again one more predicate. Okay, predicate of employee, yes. And what I'm doing, I'm just taking like base employee. So what I'm doing here it is predicate of, so this is all static method. We cannot use any other instances like what however we done for the or and and methods in previous cases, right? So it's static method we have to call always by using the specific interface name. So is equal method I'm just checking, and what is the base employee I would like to pass here it is employee one. Now I would like to compare another employee with the employee one. So how can I do that? So what I will do, let me create a new employee quickly, something like that. Okay, now see here what I'm doing by using this predicate. So that means I'm just checking this current employee is really matching to the, So with respect to this predicate, I'm just testing the current object, whatever I'm passing here, both are matching or not. So what? That is what I'm trying to match here. So in equals method, what we've overridden? We are just overridden with respect to employee ID, both are matching or not. If both are matching, then we are returning true. So if not matching, then we are returning false. So that means now guess what is the result here it is. Okay, so let me execute and observe the last statement now. What it is? False. That means what is the point here it is? Both are different employees. Now let me make, for example, employee ID 111 in the employee 2 also. So what I'm doing, base here, if you observe here, base employee just taken employee 1. So that means employee 1 is equal to E2. That is what the meaning of this line here it is. So what it is? Employee 1 is testing with the employee 2 with respect to equal functionality. So, but as part of employee functionality, what you return? You just return if both are true, then only you are considering both objects are same. So, but in this case now, yes, based on employee ID, you are saying like both are same. Okay, so here also 111 and here also 111. So 111 dot, I mean 111 employee is equal to 111 employee. So that is what we are verifying. So yes, it's true, right? It is true. So this is how the equals method is going to work inside the predicates. It's simple. One argument you have to verify with another arguments based on your user defined implementation as part of the equals method. So when you want to verify the comparability, or maybe when you want to verify the equality of object content, then you can use this equals methods with any object. Okay, so this is all about the predicate functional interface, and we are done with all the methods from the predicate functional interface. Okay, so now let's start discussion about the another functional interface called as consumer functional interface. So as of now, in function and predicate interfaces, we observe like taking some input arguments as well as returning a value also, right? But when it comes to consumer, yes, if you are understanding the meaning of consumer, it is going to consume an argument, nothing but it is going to take an argument type, one single argument, and it will not return any value with respect to consumer functional interface functionality. So then you can ask one question. So what is the meaning of taking an argument in as an input and not returning any value? So that means what kind of scenarios we are going to use this consumer functional interface, right? So let's try to have a scenario oriented solutions even related to the consumer functional interface. Okay. Okay. So here the consumer is giving a definition something like this interface accepts one argument, but there is no return value. No return value. So that means in what kind of scenarios we are going to use this kind of functional interface implementation. I'll try to tell you one or two scenarios here it is. So I just created a new class for consumer examples. Okay, let's take a example like this. For example, I have list of values like names. Okay, and I want to print all in uppercase. So what I have to do? I have to print everything in the uppercase, and I have named something like ABC, comma XYZ, comma okay MNO, something like that PQR. I have names like this. So, but I want to print everything in the uppercase like that. So what I have to do? So what is my requirement in this case? I would like to take each and every argument and I would like to print everything in the uppercase. So what I'm doing, see here now, I'm just taking the consumer functional interface now. And what is the object type? Here it is this type string, right? So let me take to print an uppercase equal to, so whatever the value I'm getting, string dot out dot println, right? And just need to make it as to uppercase. Right? So this is what I have written here. So this is how I return my consumer. Now how can I process? So even I can use individually this consumer also. For example, what I can say, And what is the method available inside the consumer? So if you go to the consumer, so what is the abstract method available here? The main method, accept method as part of our functional interface consumer, right? So we are providing implementation to the which method now? Accept method. So performs this operation on the given argument. So that means whatever the operation you defined as part of implementation, so whenever you are calling accept method, the same thing will be performed by the consumer implementation. So you have, for example, like given Dilip Singh. Now in this case, guess what is going to happen? So the Dilip Singh value is just passing here, and that is just passing here and converted as uppercase and finally printing when you are calling the accept method. So let's see, fine, right? So that is also fine, just like an example. But what about these values? So generally nowadays, when you are just using the couple of methods like for each method from the list. Yeah, for example, if you go to the list, like my list is names dot and for each. If you observe here, what is the for each method argument type consumer type. So that means they are expecting a consumer type implementation as part of for each method. So whatever you defined as part of the consumer implementation, in this case you defined as printing the uppercase. Tomorrow you can define any functionality based on the input argument, whatever you are having. You can define any functionality without returning a value kind of thing. So for everything, whatever you define logic here, that will be executed in the case of the consumer implementation wherever you are passing. See here now. Now in this case, what is going to happen? Guess. So from the list, from the names list, first name will be taken, and base for each means everyone one by one will be taken and applied the same consumer. So that means converted to uppercase and printed, converted to uppercase and printed. This is also converted to uppercase and then it is printed. Like that, every value will be okay converted and as well as printed. So see here now, this is all you got in the uppercase like this. So what you observe here, it's taking input value, it's just processing but not returning anything. Here it is. In such cases, you can define the consumer implementations. Okay. So this is what one example I can give you. And one more example what I can give you here it is. For example, assume I want to add the uppercase values to the a new list again. What I have to do? I have to add the uppercase values to the new list again. So what I'm going to do now, so I'm just taking consumer of, okay, here also string, and I will just make it as add to list. Okay. So what is the value you are getting? Always string, right? And what you can do, so just define a new list also. So the new list with uppercase values, like what I will do, list of string new values, something like that, equal to new array list. Okay, so what I'm going to do, new values dot add, I can pass here, right? I can pass new arrays here also. So in this case, what is happening? You are just passing input as a string value and you are just adding to the, you are processing that value and you are adding to the array list, but you are not returning anything here. So now what you can do? So let me call this consumer also now. So what I'm going to do now? So same thing, I'm just trying to pass again names dot for each. Okay, what I'm passing this time? Add to list. Add to list. So in this case, what will happen? Taking values from the names, converted to uppercase and added to the new values. So let me print now the new values is really contains all uppercase values or not. So let me execute program. So see here, it just what it is printing only lowercase values. That means okay. So what I'm doing, I'm just converted to the to uppercase. So now see, it's just like added all uppercase values from the old list to the new list. So like that, whenever you have a requirement, you are processing the value and you are just making kind of some operations, but you are not returning any result back to the, okay, the consumer caller. So then you can go with the consumer one. So, and even when you observe the consumer, we have one more method called as and then methods. So it's just again, it is just like similar to our function and then method only. So it is just going to compose couple of consumers by using and then method. So what is the point here? It is and then means when you are having consumer one and consumer two. So when consumer one is happened, and then it is going to execute this respective consumer also. So that is how you are going to define and then method as part of consumer. Like it is similar to function and then methods only. Okay, you just refer the function example and you just follow same thing as part of consumer. Same behavior it is. Only thing is you are not returning any values with respect to consumer. That's all. So this is all about the consumer functional interface. Okay. So now let's go back to the supplier functional interface. So what is the functionality of supplier interface? Now we will have a look here. Okay. So let me open the supplier interface once. Yeah. So if you see here, supplier interface, we have only one method called as get method as a abstract method, and we don't have any default or static methods inside this interface. Okay. But at the same time, this get method is not taking any input value, but it is trying to return a return value. So that means it's not taking any as an input as any argument, but it is returning some type of values always. So what is the meaning of this is we will try to understand. So just like this interface has to act as a supplier of a results, nothing but assume I want to get database connections always by default. I don't want to pass any information, but I want to get a DB connection every time whenever I'm calling the supplier get method. Okay. So that means you are going to provide implementation to the get method. Inside the get method, you are just providing all the logic to make the database connection or getting the database connection, right? So whenever I'm calling the get method, I used to get always a new database connection to perform my database operations. So that kind of examples I can take here. Okay. So that is the meaning of supply heritage. It's just supplying the object, supplying the different values when you are calling the different number, different times you are calling the get method, you are going to get different results. That is what the meaning of supplier functionality here it is. I just created a new class for the supplier class. Okay. And then what I'm going to do here, see, for example, I want to get date and time always. Okay. For example, this is how I have a requirement. Now see what I'm doing. I'm just taking supplier here also, and I'm just taking kind of local date and time. So that means what is the value I'm going to get as a result always is local date and time instance. Okay. Date, time equal to. So what I'm going to do here. So you know that it's not taking any input or method arguments. So the get method especially, right? So that means zero arguments. So what I'm going to do now here as part of implementation, local date time dot now. So that means what is going to happen, guess now, whenever you are trying to call this supplier, every time this implementation will be executed, and this implementation should has to return always this type of object. So tomorrow if you are making something like database connection, if you define DB connection class name here, and whenever you are processing the database details and you are making a database connection, you should return your this implementation should return the database connection object whatever you declared here. Then whoever is calling this your supplier, they are going to get the database connection always without providing any input values, or maybe without sending any data. You are always getting a dynamic database connection. In this case I'm going to get a dynamic time also with respect to my supplier implementation. So see here, for example, date to time dot, what is the method? It is get method, right? get method. So you're going to get which object? Local date and time objects. So this is the get method belongs to the supplier interface. So let me test it now. So see here now, what is the time you got? It's just like 23 and 5404, right? So let me execute same example one more time. So see here 23, 54, 13. So that means the data is changing always. It's like 17. After 1 minute, you will get like 55. So that means it's keep on producing the results. Whenever you're calling, now next, maybe for example, assume you're calling again, second time also, or that means what is going to happen? It is going to give one more results. Same results or maybe different results it may produce, depends on our logic implementation as part of this method. Okay, so you got the point. Even sometimes, I mean, we can pass the supplier instances to the other methods as an arguments also. For example, if you see here, what I'm doing here it is, for example, public, I'm defining a method, something like static method, whatever it is, and void print current time now. Okay, so just I'm writing a method like this and observe here how I'm defining a method here with respect to suppliers and what is the time I'm going to pass here. It is local date and time. Okay, so date, time. So I'm just passing here. So what is the method argument type here? It is supplier type, which is accepting or sorry, which is returning always a local date time object. So similarly, you can define any type of objects here and you can pass that supplier object as a method argument also. So see here, now how I am calling this method print dot, what is the, sorry. So I'm going to call this method, I need to pass what? Supplier object. So I already have a supplier object, right? So let me call here now. So then what you are going to do now? So here you will receive always a supplier object. Let's call the method and then you will get the time and you can print it also. What we did, let me disable this code once. So whatever the supplier object you created here, that supplier implementation you provided here, you are simply passing that implementation or that reference to the another methods also as a method arguments. So similarly, the other functional interfaces what we discussed, predicate function as well as consumer, those are also we can pass as a method arguments wherever we want. Okay, so you just try to explore how to pass the functional interface implementations as a method arguments. Okay, so let me execute now. What is going to happen? This, you are just passing this implementation, supplier implementation, you are passing to this method. So then overall it is contains this implementation here. So from that you are calling the get method of abstract method of the supplier class. So that means finally this will be executed, this implementation will be executed when you are calling the get method, because you know that this lambda expression is implementation of the abstract method of functional interface. So let me execute now. So see here now you got the data. So but with this time I taken an example passing as a method argument also. Okay, so that is all about the predefined functional interfaces, which are very popular in our day-to-day functional programming or when we are using stream API programming or in anywhere else, right? So most of the times we used to see these four types of predefined functional interfaces in our day-to-day programming. Okay, so that is the purpose. I just taken very carefully and I applied all the scenarios how to understand, especially these four predefined functional interfaces. And when you observe the, okay, when you observe the same package again one more time, not only these four, you can observe there are a lot of other functional interfaces available which are provided by the Java language. But what is the point you have to remember here? It is these are all the remaining all functional interfaces, whatever you can see here it is, it's directly or indirectly designed or derived from the four interfaces what we discussed right now. Okay, like function, predicate, consumer as well as supplier, right? So these four behaviors are represented in every other functional interface whatever you can see here it is. Okay, for example, if you see here consumer, we know that it is going to take one input but it is not going to return any value. But if you see here by consumer, in the sense it is going to take two input values, but it is not going to return any value. But when you are understanding the function, it is going to take two arguments and it is going to return a value, right? But here these guys are saying like, yes, these guys are saying they are going to take two inputs and they are going to pass values. Once you are good with these four types of functional interfaces understanding and all, we can understand all these other functional interfaces which are presented in this package, because these are all directly or indirectly implemented from the four functional interfaces what we discussed right now. Okay, so that's all related to the predefined functional interfaces. In the next topic, I'm going to cover more about the optional class, and then immediately I will start taking a new session about stream API programming, which are being very popular nowadays in with respect to every interview as well as in every real-time application. Yeah, thanks to everyone. So thanks for watching.